Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. In the problem statement, we have a hexahedron of 30 sides, which is resting on one of its corners on the HP such that one of its solid diagonals will be perpendicular to VP. We need to draw the projections of the solid. So we can understand that a hexahedron here is nothing but a regular cube of 30 sides. So that is all the length, height, and the width will be equal to 30 And the resting condition is it is resting on one of its corners. And the given parameter here is one of its solid diagonal. So we shall first understand what is the concept of solid diagonal. So for that, let us simply draw a cube of any arbitrary length. To understand the concept of the diagonal and the solid diagonal, let us now consider a cube which is shown here. So it is a cube that is A, B, C, D, E, F, G, H. So now let us understand the concept of diagonals. So we all know that a cube has got six faces, and if I'm going to join the opposite points on the faces, that is A to C and B to D, it becomes the diagonal of that particular face, that is ABCD. And similarly, the faces, for example, B to H and G to C. So this becomes the diagonals of the face BGHC. But now the question tells us that we need to consider the solid diagonal. So what is solid diagonal? We'll understand. So if I'm going to join A to H or D to G or C to E, this becomes the solid diagonal. So simply speaking, the solid diagonal is the diagonal which is joining the extreme corner points of the opposite faces. That is ABCD is here and the opposite faces EFGH, and the solid diagonal is the diagonal which is going to join corner A to corner H or corner D to corner G. So here corner F to corner C, and here it could be from corner E to corner B. So this is the concept of solid diagonal. So after having understood the concept of solid diagonal, now let us draft the solution for the given problem statement. Let us begin by drawing the XY line of thickness 0.18 mm. Annotate the line as X and Y. And also the reference planes as VP and HP. Now let us complete the top view of the hexahedron. So we'll assume that it is a regular hexahedron of 30 So it is nothing but a cube. So let us select the line of thickness 0.50 mm. Select the rectangle option and then let us construct a square which is equal to 30 in both length and the width. And also the resting condition is it must be resting on one of its corners. So this is the top view of the cube which is resting on one of its corners. Let us draw the projection lines. Cube is also having a height of 30 So let us draw the axis of 30 but however the axis will be overlapped by the edge line. So let us draw the edge line measuring 30 in height. And then complete the top and the bottom faces of the cube. So we are going to draw the solid diagonal. So for that, consider a line of thickness 0.13, and then from this corner to this corner we are going to draw the solid diagonal. So now let us do the annotation for both the top and the front views of the cube. So let us tell that it is resting initially on the corner A1, which is not seen to the observer in the top view, so it is inside the bracket. But however, the corner of the top face, that is A1, is seen, so it is outside the bracket. And next it is corner B1, and then we have got the corner C1, and next the corner D1. Next, let us annotate the front view of the hexahedron. So here the corner A1 dash is visible to the observer, and this will be the corner A dash. So this is the bottom face of the hexahedron, and this is the top face of the hexahedron. And while this is B1 dash, inside the bracket it is D1 dash. And next here we have got B dash and D dash inside the bracket. And here we have got the corner C1 dash and the corner C dash. So this is the indications of the front and the top view of the hexahedron. So the solid diagonal here is C dash to E1 dash. So this is the solid diagonal. So according to the problem statement, we have got the solid diagonal perpendicular to the VP. So that is in the third position. This solid diagonal, that is C dash A1 dash, must be perpendicular to the VP. So we are going to rotate this hexahedron in the second position in such a way that this solid diagonal, that is C dash and A1 dash, will become parallel to the HP, and hence in the third position it is going to appear as if it is perpendicular to the VP. So for that, let us select the front view of the hexahedron along with the annotations and the solid diagonal. And then let us move the front view by keeping the point A1 dash as the reference. Now select the rotate option. The first point of rotation is C dash and the next point of rotation is A1 dash. So we are going to rotate C dash A1 dash at an angle of 0 degrees, and then move the corner C dash to make a contact with the XY line. So this is the hexahedron with one of its solid diagonal, that is C dash A1 dash, parallel to the HP in the second position. So now let us complete the top view of this hexahedron by drawing the projection lines. So now we are going to complete the top view of the hexahedron. So we shall consider the farthest point for the observer as C1 dash. So from C1 dash, all the edge lines will be hidden and the outer edges will be the visible lines. So now let us select a line of thickness 0.50 mm and let it be a dotted line. So the corner C1 dash is here. So from here, all the lines will be the hidden lines. So C1 to D1 Also C1 to B1 will be the hidden lines. So the rest outer edges will be the visible lines. So let us complete the top view of the hexahedron. And also the edge line connecting C1 to C will also be the hidden line. So select the trim option to trim the projection lines which was not required for our constructions. So this completes the top view of the hexahedron. So now let us annotate the top view. So this is the top face of the hexahedron. So this is the corner A1, and here this is the corner B1, while here this is the corner C1, and here this is the corner D1. And next we have got the top face of the hexahedron. So this is A, corner B, corner C, and then corner D. So this solid diagonal, as you can see here, it is C1 to or C to A1, so which is parallel to the HP. And now we have to rotate this in such a way that it will become perpendicular to the VP in the third position. So now let us select the top view of the hexahedron. Okay, so here this edge lines is not connected, so let us complete that. That is A to A1. So now we can select the top view of the hexahedron. Select it along with the annotations so that drawing the projection lines will become easier. So now we are going to make a copy of this, and then keeping A1 as the reference point, we are going to simply move this towards the right hand side of the HP. And now let us select the rotate option, ensure the copy is off. So keeping A1 as the first point of rotation and C as the second point of rotation, we are going to rotate in such a way that this solid diagonal, that is C to A1, will become perpendicular to the VP. You can see this, that is C to A1 is perpendicular. So we'll move this to a comfortable position. So now you can just see this, the solid diagonal, that is C to A1 is perpendicular to the VP. And now we are going to complete the front view. So let us draw the projection lines of thickness 0.13. So let us draw the projection lines in the vertical plane, and also the projection lines from the horizontal plane. So now we have got the points of intersection of the horizontal and the vertical projection lines, and now we shall complete the front view of the hexahedron. So select a line of thickness 0.50 mm. Let us begin with the corner A1. So for the observer, the corner A1 is the farthest point. So first we'll complete the hexahedron and then go for drawing the hidden edges. So let us start with the top face, which is ABCD. So A is here, and then we have got to join this corner A to the corner B. So corner B is here, and then from corner B to corner C, and then corner D is here, and then back to corner A. This is the top face of the hexahedron. Similarly, we'll complete the bottom face of the hexahedron. So we have got the corner A1 here itself. So we are going to start from A1 to the corner B1, which is here, and then the corner C1, which is on the XY line, and then corner D1, so the point of intersection or the end point of this line, and then back to the corner A1. So we'll connect the corresponding parallel edges. So the edges from A1 will be the hidden lines, and also these inner edge will also be the dotted line from A1. So let us complete the annotation. So this is A dash, this is corner B dash, corner C dash, and corner D dash. And coming to this, so here it is A1 dash, corner B1 dash, and then the corner C1 dash. So you can just see that all the points, that is A dash, A1 dash, C1 dash, and C dash, will all lie on the same projection line. And then we'll complete it with the corner D1 dash. So now you can just see that the solid diagonal that we have considered in the first position, that is C dash to A1 dash. C dash to A1 dash is perpendicular in the vertical plane. So with this, we complete the solution for the given problem statement. So to sum up, we have got a hexahedron of side 30 mm, which is resting on HP on one of its corners. But however, the condition given to us is one of its solid diagonal is perpendicular to the VP. So if this solid diagonal has to be perpendicular to the VP, in the second position, we are going to rotate it in such a way that it is going to be parallel to the HP, so that it appears to be perpendicular to the VP. So this is the solution for the given problem statement. Thank you all for watching.